Now let us start the second problem on the shear force and bending moment diagram. This is the simply supported beam with the point load as well as the uniformly distributed load. Okay, so now we will start to model this in Ansys Workbench. So first of all, we need to create the engineering data in that 200 gigapascal we have to give. Afterwards, we have to model this at 2, 2 and 4. Okay, so let us start. Let us go to engineering data and here 200 megapascal. By default, it is there. Okay, so Poisson's ratio 0.3 is there. We'll close this. Next, let us go to geometry. Okay, in geometry, we need to create three elements. Okay, so in three elements of length 2000 mm, 2000 mm, and 4000 mm. Cross section is 40 by 20. Now let us draw the three elements. One is 2000, another one is also 2000, the last one is 4000. Let us check the dimension. It is correct. Now the cross section is 40 by 20 mm. So now go to prepare profiles, select the rectangle, right click on rectangle, edit beam profile. You edit the breadth to be 40 mm and the height to be 20 mm. Now we have created the cross section. Now just close this SYS and then go to structure, design. Okay, now assign this. So you should get an anchor symbol. Yes, anchor symbol you got. Click on rectangle, click on this and click on rectangle. So each time you're clicking this uh, beam and rectangle, it will assign the same value of the cross section to all the elements. So once done, you click on design and share topology, go for share and close the window. So now double click on the model. Now the model is opening. So after the model opens, you have to do the meshing. Now you have the elements here. So now let us go to mesh and generate mesh. So we have created a mesh of the beam. Now what you need to do is go for applying the load, insert, force, vector you change it to components along y direction. Okay, so y direction load is 30 kilonewton, so minus 30,000, press enter and click on the first particular point. So create one more force, okay, whose magnitude is 20,000. Yes, 20,000. So minus 20,000. So now create the same on the next particular. So there are two point loads are there in this problem. The one more is the uniformly distributed load from 4 meter to 8 meter. Okay, so now what we are going to do is to apply the uniformly distributed load, insert, you click on line pressure. Line pressure, you click on line pressure and the vector you replace by components, and you are going to apply in the y direction, that is minus, which is down. So 10 kilonewton per meter, if you convert into newton per mm, it will be 10 newton per mm. So you click on the, now don't click on the vertex, you have to click on the edge, last edge you have to click. So now uniformly distributed load has been applied. Now finally we need to apply the boundary condition, which is remote displacement. Now remote displacement has to be applied on the first and last vertex. So we'll select the first vertex, where we'll give the first one as 0, so x, y, and z also it cannot move, and the rotation x also, rotation y also. So it is clear that it is all x, y, z are 0, and rotation x, y are 0, rotation z is free. Okay, so now again you need to apply one more remote displacement, that is boundary condition on the right extreme end. So you select, now here you have to give x is free, because x, it can slide in the x direction. So we are providing for a roller support on the right hand side, so it can slide in the right hand side. Okay, so provided free 0, 0, 0, 0 free. So we provided all the things. Now go solution. Before going to that, let us go for creating the path. Insert construction geometry path. Okay, so 2 points you remove and go for edge. Select first, go for selecting the edge, first edge. Okay, second edge plus, third edge plus. So you created the path. Now go for solution, right click, insert,